Hello and welcome back to another video on my YouTube. Today we're going to be trying out this Cambridge STEP question that came up in the 2005 paper. So in this question, A and B are both distinct, non-zero real numbers, while C is a real number. For part 1, we have to show that if A and B are both positive or both negative, then the equation on the screen here has two distinct real solutions. Immediately, I thought we had to make the denominator the same on both fractions on the left hand side. So what I've done here is made the denominator the same by multiplying by x minus b on the left and multiplying by x minus a on the right. The colours on the screen that you can see are just for making the equation a bit easier to see as we progress and simplify. So once we expand and multiply out the denominator, getting on the right hand side, we can expand the equations to get x squared minus bx plus x squared minus ax is equal to x squared minus bx minus ax plus ab. And I'm going to quickly simplify this by moving everything to the left hand side, and we're just left with x squared minus ab because the bx and the ax cancel out and 1x squared is taken away from 2x squared. This is a core skill that we're going to use next. It's called the discriminant. There's 3 rules for the discriminant. Because we have to show that the equation has two distinct real solutions, the discriminant here must be greater than 0. If we needed one solution, it would be equal to 0. Meanwhile, if we did not want any solutions, it would be smaller than 0. The discriminant may look quite familiar to you because it's in the root of the quadratic formula. But for now, we're going to put the values of ax squared plus bx plus c into the discriminant. In this case of x squared minus ab, there is no b termed, there's no coefficient of x. Therefore, we can simply equate what we've just done as something being greater than 0, and now we get 4ab as greater than 0. In the question it says we have to prove that a and b are either both positive or both negative. Seeing as 4ab must be greater than 0, there's only 2 ways that could ever be the case. If a and b are both positive or a and b are both negative, 4ab will be a positive number. This is because positive multiplied by a positive number gives a positive result. Meanwhile, a negative by a negative gives a positive result as well. And that's part 1.